So one more example of inter-VLAN routing with multiple switches. In the previous class, I had just one switch. So this one switch, earlier, before this lab, we did with the router on a stick with two switches. So what today we are going to do is, we are going to add these two computers to another switch. That another switch need not to be a layer 3 switch. It can be a layer 2 switch also. It can be like this. Because we have one switch, high-end switch with more money spent. I no need to have another costly switch. If you have, you can use it, but I'm pretending as if, my company is not ready to buy another costly switch. So I'm provided with only this switch. And I want VLAN 10 member of this A to talk to B as well as to D. This is 10 VLAN, 10 network. Talking to D is 20 VLAN, 20 network. Talking to B is also 20 network. But the difference is this is in the local switch. This one is in the remote switch. All right, I don't need a router. This is not a router on a stick. In what way it is different from the previous lab? In the previous lab, I just got only one switch. Now I got more switches, in which only one is a layer 3 switch. One is the multi-layer switch. All others are normal layer 2 switch, layer 2. Easy, nothing big. We need to just go and make the VLAN interfaces and trunk interface. Interface, what is it? F0/3 is a trunk. Same way on this side on 3. Interface F0/3. This is a multi-layer switch, so if you say switch port mode trunk, it won't accept. Oh, it is accepting. Good. Okay, that's fine. In some switches, you need to say switch port trunk encapsulation .1q. After that, only it will accept switch port mode trunk. But in this switch, without this command, it worked. But in some multi-layer switches, you must type this command before you type this command. All right. In layer 2 switches, we don't need actually this one. But when you try typing this command switch port mode trunk, if you didn't accept, do this first. Earlier, like few days before, we learned the difference between .1q and ISL. .1q is now popular. ISL has lost its popularity. The reason is the encapsulation takes more number of bytes in ISL compared to .1q. If you forgot these things, you need to go back to the beginning videos of switching. Now, I have configured this interface as a trunk F0/3. Let me check. Show interface trunk. You can see F03 is trunking, but I don't have the VLANs 10 and 20. Let us create VLAN 20 and 10, VLAN 10, VLAN 20. And now, next thing I want to do is assign the interfaces. This one, F0/1, if you see, it is connecting to VLAN 10 member. So I'm saying switch port mode access, switch port access VLAN 10. Also, I'll go to interface F0/2, switch port mode access, switch port access VLAN 20. All right. show VLAN brief. You can see here the interfaces are assigned to the right VLANs. And do anyone know why F0/3 is missing? I can see F0/1, 2, and then 4. What happened to 3? Where is F0/3? Yeah, trunk port will not be listed here. Hmm? Show interface trunk, because it is trunking, it won't be listed there. This trunk link is allowing these two VLANs plus the default VLAN. As of now, we have only these three VLANs. Okay, now we will be able to ping, you see. I can ping from here. This IP address of the computer is 10.0.0.1. I can ping 20.0.0.1, which is in another VLAN, but on the same switch. I can also ping 20.0.0.2, which is on another switch. All right, so this is possible because this device is a layer 3 device. This is also doing routing along with switching. Let me show you what we did in the previous class. We did show interface brief. We created show IP interface brief. We created two SVIs, meaning layer 3 VLAN interfaces. And we gave IP address. And also we gave this command IP routing. You see, show run. We gave this command IP routing. Because of this reason, what is this show running? Show running is the command that shows all that you have configured. See, I have named it as SAM in the previous class. I put IP routing, and then I assign this interface to the VLANs, and then I have a trunk link, and then I got VLAN interface with IP address, two VLAN interfaces. We did not give the MAC address, it automatically comes, so no need to worry. It's dynamically generated and assigned. And show IP route, you can see the routing table for VLAN 10 and 20. As a result, you are able to ping it. So when I pinged between A to D, what happened is, see, A is 10 network, VLAN 10, D is 20 network, VLAN 20. So what happened is packet goes to the gateway, which is gateway, the routing table, you see. It went here, and then it was looking for destination 20. Because I was pinging what? I was pinging D. D's IP address is 20.0.0.2, 20. And it is in VLAN 20. So router can take traffic from VLAN 10 and put it in VLAN 20. Only router can take traffic from this VLAN and put it into this VLAN. As a result, it was searching for 20.0.0.2 only in VLAN 20 domain. It was searching here, it couldn't find, and through trunk it went and it found here. So you got response from here. All right. And the other time when I pinged this one, it just went like this. And it is routed, not switched. See, in this device, you have two engines. This round one is a router engine. The other one is a switch. So both switching and routing carried out. Now, if I ping from here to here, what will happen, you know? The traffic cannot go like this. Why? Because it's simply a switch. It needs routing. It needs to get out of VLAN 20 so that it needs to go here. It enters in VLAN 20 and get out of VLAN 20, it enters into VLAN 10. So it will come back like this. Right? It won't go like this. Not possible to go from VLAN 10 to VLAN 20 directly without routing. So it will always go to the gateway and come like this. You understood this now? So now what is next we are going to do? We are going to focus on another important feature called native VLAN. After that, we will go to another topic called, which I already spoke, like span, switch port analyzer, and RSpan. With this we'll be finishing the switching topic. Okay, so routing is going to be a very big topic. Now we need to learn native VLAN. See, you might have learned default VLAN, VLAN number 1. But when you go and type show interface trunk, native VLAN is also shown as VLAN 1. Native VLAN is also what? VLAN number 1. It doesn't mean that native VLAN and default VLAN are same. See, default VLAN is 1. Native VLAN is 1. But they are not same meaning. Native VLAN can be changed, but you cannot change this default VLAN. This is one important place where someone will identify how good we are in networking. If you want to test someone, you can ask this question. If they will say native VLAN, default VLAN, both are same, then they don't know switching. Native VLAN is different. Default VLAN is different. If anyone says both are same, they do not know switching. You don't know switching. You can easily identify them. VLAN 1 is the only VLAN that can be called as default VLAN. You cannot change it. But native VLAN is one because you don't have other VLANs. You just now only created this 10 and 20. This was the only one which was available, so it is assigned there. It can be changed according to your need. Now, what is this native VLAN? When do we need it? When do we need native VLAN? Let's learn. I'm going to give you two different scenarios in which native VLAN is used. In olden days, we had hub. And also switches. Now, before switch, we were having hub and a lot of devices connected to the hub. Ten dot 0.0.1, .2, .3, .4, .5, .6. 10.0.0.6. And We have here 10.0.0.7, 10.0.0.8, and 20.0.0.1, 20.0.0.2. And this is VLAN 20, this is VLAN 20, and this is VLAN 10, VLAN. Please focus. Hub will not have any VLANs. You cannot configure VLAN. You cannot create VLAN. You cannot create VLAN in Hub. But if this VLAN 10 member and this VLAN 20 member, if VLAN 20 wants to talk to this VLAN 20, if that VLAN 10 wants to talk to this VLAN 10, what is needed here? Trunk. Do you agree? Do you agree with me? You need trunk because multiple VLANs are there. You configure trunk. But this is VLAN 10. This is VLAN 10. They will talk, no problem. 10.0.0.7 will talk to 10.0.0.8 because you got trunk. But can these computers talk? I want these computers to be the part of VLAN 10. But when the hub sends the packet out, there is no VLAN marking in it. Hub don't know VLANs. Hub don't maintain. Hub don't understand VLAN. So Hub will not send any packet with VLAN marking. And you want this packet to be delivered to VLAN 10 members. You want this and this to ping. You want this and all this to ping. So what I can do is I can go and make trunk with native VLAN 10. What does that mean? I'm telling trunk port, if you receive any untagged traffic, if you receive any packet without any tag, consider them as a member of VLAN 10. That's the meaning of native. You see? Consider as a member of VLAN 10. See how meaningfully they have named it as native VLAN. See, if this is my native country, when I enter into this country, do I need to show any visa copy? Not needed. I don't need to show visa copy. I need to just show the passport and then they will stamp and then I'm in. I'm inside the country back to the native. I don't need to show a visa paper. But when I went to that country, I definitely need to show because that is not my native. I need an ID. I need to show I belong to this VLAN. But if I am native, why should I show a visa paper? No meaning. There is no visa needed for me. No one will give me visa for my own country. Likewise, when an untagged traffic comes, it is considered as native and it will be accepted inside VLAN 10 domain. It will be accepted inside VLAN 10 domain. So all these computers can ping 10.0.0.7 and 10.0.0.8. and vice versa. Now let's say you change this IP address to 10.00.10. Can these members talk to this 10.00.10? No, because this 10.00.10 is a member of VLAN 20. But these packets that go will be only allowed inside VLAN 10 because native VLAN is 10. You understand? You understand the meaning of native VLAN now? Let us try doing this. I'm going to simulate the same scenario. You see, I'll break this wire and I'll introduce a hub. This is a hub. And I'll connect. Now, I am going to have another computer connected here. And the IP address of this computer is going to be 10.0.0.3 slash 8. Let me assign 10.0.0.3. Gateway is not necessary. Now, you see, I'm trying to ping a 10.0.0.1, will not be able to reach. Ping 10.0.0.1. It won't ping. All right, I'm also trying to ping 10.0.0.1. That also it won't ping. You know the reason why? The reason is right now the default native VLAN here is on the trunk port. This is a trunk port we configured already. The default native VLAN is 1. But this computer is not in 1 VLAN. It is in VLAN 10. That's why I'm not able to ping. Whatever this guy sends, the packet will go in both the direction because it's a hub, it will always broadcast. When the packet, untagged packet is received, it is put into VLAN 1, but there is no member of VLAN 1 with the IP address. We have only VLAN 10 with this IP address. That's why I'm unable to ping both. So if you want this ping to happen, what I should do, I need to change the native VLAN. Do you understand what I'm doing? Did you understand up to now? See, show interface run. Right now, native VLAN is 1. It is putting all those untagged traffic in native VLAN 1, but there is no 10.0.0.1 in VLAN 1. We have it on VLAN 10. So I need to change this. Interface F0/3. See, I'm going under the trunk port F03 and I'm saying switch port trunk native. What? 10. I want you to focus now. See, I configure native VLAN on 10 on one side. You must configure on the other end also. Otherwise, you will get error message every 60 seconds. How often? 60 seconds. It will say native VLAN mismatch. Go and see on the other switch. It's going to come, you see. You'll see on the other switch now. You see, this guy will quickly look at this. It says, Mm, they're all spanning tree. VLAN, it's okay. But I'm waiting for the native VLAN mismatch. It will come. Show interface trunk. You see, I have changed the native VLAN to 10. Look at this. This will come every 60 seconds saying we are using 10 as a native VLAN, but the other switch is using VLAN 1. Native VLAN mismatch. This is not good, good one. You should go and change on the other switch. So I'll go to the second switch. You see here also, you see the same. It says that switch called SAM is using 10, but locally we are using 1. Okay. Let me say hostname J. Now you will see native VLAN mismatch with the name. How it knows the name of the other switch? There's a protocol called CDP, Cisco Discovery Protocol, which can even learn the host name of the other switch. All right. You see, native VLAN mismatch again. It is discovered that the SAM is using VLAN 10 as a native, but we are using 1. Here, what it says, J is using VLAN 1. Locally, we have 10. So go to J and configure switch port trunk native VLAN 10. Now the error won't come again. All right, the error won't come again. And now it is ready to ping. If you want to ping now, you can ping very well. You see, it will ping. Look at this. It pings now. Because all the untagged traffics are sent inside VLAN 10 domain. You understood native VLAN now? Wonderful. So the next topic is span. Switch port analyzer. Switch port analyzer. What it is? Assume that in a 48 port switch, on the 48th port, F0/48, on the 48th port, you have connected to a computer where you have a analyzer, meaning you're running some tools for auditing. What auditing? Network. You're monitoring here. You are a security engineer. You are monitoring all the traffic that enters into every single port of the switch or one of the port. It depends. You see, let's take this example. This link is connected to the internet. So any traffic that enters into this port, as well as the traffic that leaves this port, let's say this port is F02. I want to monitor. I want to see what traffic is coming in, to whom it is coming in, and what traffic is going out, from whom it is going out, who is sending the traffic out. I want to monitor. I want to do monitoring. I want to watch who is sending packets, what sort of packet they send, from where they send, to whom they send, from where it comes, to whom it comes. You see, seamlessly someone can monitor like this. You will never know that someone is monitoring us. They can do this with the help of this feature called span. Switch port analyzer can allow you to do this. Span helps to monitor without the knowledge of those devices that is communicating over that F0/2 port. Only those traffic that enters and leaves this port I want to monitor. That is one option. I can also monitor all the traffic that enters into VLAN 10 and leaves VLAN 10. So in VLAN 10, you may have 10 computers. So all 10 computers traffic can be monitored. I can also monitor a port channel. You remember we learned port channel, which is a virtual interface. So these are all the options that you have in span. Now what is span? Let's say A is talking to Yahoo. When A sends the packet, it will try to go out of this blue port. It will try to go out of the blue port. But because you have configured span, blue port will just duplicate the copy of a packet, of the packet that you are generating. A is generating packets. All the packets will be duplicated and it will be sent to this port. A duplicate, a copy is made. So span is also called as mirroring. Mirroring, duplicating. Neither Yahoo nor computer A knows that our communication is being monitored. They will not know because it's not the same packet. A copy of the packet is sent to the analyzer. This process is what called as span. What? Taking a copy and putting into the desired port for monitoring. I'm sending to my desired port is F0/48 because that is the place where I have connected my analyzer. Yeah. So wherever you have analyzer, you can send traffic of any single port or any port channel port or traffics of a particular VLAN. This is what we call it as span. This technique of taking a copy and sending to a desired port is permitted, is granted by this feature called span. Did you understand what is span now? Okay. When I show you the commands, when I do this, you will understand better. One thing I want to tell you, this span is not a auditing tool. Span is not a cybersecurity tool. Span is not an analyzer. Span is just a feature in a switch that can take a copy of traffic and give it to the port where you are running some special tools. You have installed a special tool here. That's not provided by span. That is your contribution to this. You have a computer on F0/48 with all the auditing tools, but you're waiting for the traffic to come for monitoring. So how do you make the traffic to come? Doing this span. See, You cannot go and sit here and monitor. Not possible. It will be a disruptive one in the path. But that is also done in IPS device, intrusion prevention system device. But this is another method. We do not want to sit in the path. We just want to sit remotely and analyze. See, when you come to India from some specific countries like some part of Africa or some part of the Middle East, this is what happening. Someone will be sitting in the room and monitoring every passenger. The way the passenger is walking, the dress code, the bag that he carries, the eyeball movement, everything they will be monitoring very closely. Even your very close friend might have not seen you that close, but these people will be seeing very closely your packet. When you move your hand inside a packet, they want to see what is that inside the packet. How big is the thing inside the packet? What is he taking out? So closely they will keep the monitor. They will keep the camera. You won't see the camera, but they zoom it, and they see what you are taking out. And they'll come and stop. Not everyone, exactly the right person who has got some extra gold in the packet. Because this guy is nervous. From the moment he got down from the flight, his walk, the way that he stands in the queue, and then the way that he is looking at the scanning machine, everything they monitor. The customs are very bad. Even though we paid money and bought that gold, they will treat us as if we have stolen from somewhere. Just to get some small money from us, they treat us like that. We will not know that someone is monitoring that close to our neck, how much gold he is wearing in the neck, close to our bracelet, close to our fingers, how many finger rings he is wearing. Yeah. When they see you rich, they will stop you and say, the value of this gold is more than 2 lakh. So you have to pay this much of duty. That is spam. You will not know that someone is monitoring, but they are monitoring. But there are some countries, they don't do spanning. They do inspection. They'll stop you. They won't allow you to easily go. Guinea money, Guinea money, Guinea money. What is Guinea money? Actually, it's a country called Guinea. He's asking for money. When he was returning from that country, I was trying to board. This fellow security guy stops. Unnecessarily, they will stop and they will check all the purse, bag, everything. If they don't find anything, they will say, Guinea money. Give me some money, man. Then you can go. And they will beg, but they will show as if they ask by power, authority. Actually, they're begging. But they won't show us begging. They will just pretend that they are authorized to do that. That's not spam. that is interrupting in your way, sitting right here. You know that we are being monitored in that case. But in this case, in span case, you will not know you are being monitored. A will not know, Yahoo will not know, but actually the conversation is being monitored. For that, switch without the support of the switch, it's not possible. It's not possible for you to monitor passively without the feature called span, because the span can duplicate the traffic and give you are able to do that monitoring. I hope you understood now very well. Now let's get into the next topic called RSpan. RSpan stands for a remote span. Remote. RSpan or remote. R means remote here. Remote span. RSpan. What is it? In what way it is different from the above one? You see, this is the port where internet is connected, and that is switch 1. And I got a trunk link because I got many VLANs, also VLAN 10, VLAN 20 members in switch 1. Likewise, I have another switch with VLAN 10, VLAN 20, VLAN 30. This is the only port via which VLAN 10, 20, 30, they all get routed. This is a multi-layer switch. They all get routed and they go online. And here also we have VLAN 10, VLAN 20, VLAN 30. Now, the analyzer is here in the second switch, not on the first switch. The auditing tool is in switch 2. In the early case, it was in switch 1, same switch, 48th port. Now you understand this R remote. I need to send the copy of all the traffic to a remote port on a remote switch. To a remote port on a remote switch. How to do this? Very simple. I need to create a VLAN here and here. Let's say VLAN number 40. So I have to take the traffic from this port F02, put it in VLAN 40, so that as VLAN 40 it will be carried, and here in this switch I'll take it from VLAN 40 and give it to this port, let's say F0/20. So any traffic that go out of this port or get inside of this port will be audited from here, because a copy is taken and given to a VLAN instead of a port. Why? Because through VLAN only I can carry to the other switch. So through VLAN 40 it goes to the other switch. In VLAN 40 I can see those traffic coming. So I now copy from VLAN 40 and I give it to this port. So VLAN 40 is only dedicated for this purpose called span, not for any other traffic. This is what called as RSpan, remote span. Did you understand remote span? Okay. So in our next class, we are going to do this lab. Native VLAN lab I just finished before this. It was the last lab we saw, native VLAN. Try doing it with a hub in the middle. In our next class, we are going to do span and our span. It won't take more than, let's say, 20 minutes. After which we will get into very interesting routing topic. Routing will go months